Hi, the points P and Q have position vectors 1, 2, 3 and 3, 3, 5 respectively, referred to an origin O. Find the position vector of the point where the line PQ meets the plane Z is equal to 0. Also find the equation of the plane through P normal to PQ. And find the angle OPQ, giving your answer to the nearest 0.1 degrees. And for the fourth part, find the values of A, B, C such that the equation of the plane OPQ is R.1AB is equal to C. Right. Okay, for this first part, we're going to have to find first of all the vector PQ. What is the vector PQ? It is PO plus OQ by geometry of vectors. PO is minus 1, minus 2, minus 3. Plus 3, 3, 5, and that's going to give us 2, 1, and 2. So this is the vector PQ. We need to find the position vector of the line PQ, alright? So of the line PQ where it intersects or meets the plane Z is equal to 0. What is the vector equation of the line PQ? Now remember we have a coordinate here 1, 2, 3. So vector equation of line PQ can be given as x minus 1 divided by 2, then we have is equal to y minus 2, this is 2, divided by 1 is equal to z minus 3, okay, divided by 2, and all of that can be equal to lambda. Now we are told that it meets the plane z is equal to 0. What is the plane z is equal to 0? It means that this is the xy plane. Okay, so if z is equal to 0, I can clearly say that z minus 3 divided by 2 is equal to lambda, and z is equal to 0. So 0 minus 3 over 2 is equal to lambda. In other words, we're saying lambda is equal to minus 3 over 2. Therefore x minus 1 over 2 is equal to lambda minus 3 over 2, meaning that x is going to be equal to so 3 over 2 times 2 plus 1. X is going to be minus 3 times, so minus 3 plus 2 is minus 2. And also we have y minus 2. Y minus 2 is equal to lambda, and lambda is minus 3 over 2. So y is going to be minus 3 over 2 plus 2, and therefore y is going to be 1 over 2. Therefore the position vector of the point, of that point where it touched the z is equal to 0 plane, is going to be x is minus 2, and then y is going to be half, and the other one is 0. So this is the position vector of the point where the line PQ intersects the plane xy. Here we are for the first part. Now then, for the second part, we need to find the equation of the plane through P normal to PQ. But first of all, what is the vector PQ? Now PQ can be PO plus OQ, and PO should be minus 1, minus 2, minus 3, plus OQ, and OQ is 3, 3, 5. And that's going to give us 2, 1, 2. Right, so now this is the vector PQ. Normal to PQ, and we need to find the equation of the plane. Therefore we have 2, 1, 2. So 2x plus y plus 2z is equal to d. Now we can substitute any of the points. Let us take OQ. 2 times 3 plus 3 plus 2 times z, and z is 5. So d, and that's going to lead us to d being equal to 6. 6 plus 3, 9. So 9 plus 2 times 5 is 10. 10 plus 9 is 19. Therefore the equation of that plane can be given as 2x plus y plus 2z is equal to 19. Now for the third part, we have to find the angle OPQ, giving our answer correct to 0.1 degrees. Now OPQ will be then vector OP times vector PQ, and all divided by the magnitude of OP times the magnitude of PQ, and that's going to be equal to the cos of theta. Therefore OP is, as given in the question, 1, 2, 3. OQ is, no, PQ is 212, so 212 divided by the square root of 1 square plus 2 square, which is 4 plus 1 is 5, 5 plus 9 is 14, times the square root of 2 to the square, 2 to the square is 4 plus 4 is 8, plus 1 to the square, so that's going to become 9, cos of theta. Therefore cos of theta is going to be equal to 2 times 1 is 2, 2 times 1 is 2, 3 times 2 is 6, 6 plus 2 plus 2 is 10, so 10 over 3 root of 14, it's going to give us 0.8909. Check it out in your calculator. Alright, so we're going to get inverse cos of 0.8909, 27.0. Because we are not told to find the acute angle, so we can find the obtuse angle, minus 153.0. So we can say that this is going to be 153.0. Now that's the third part of the question. Now then, for the fourth and final part of the question, find the values of A, B, C such that the equation of the plane OPQ is R dot, this should have been 1, sorry, R dot 1 AB is equal to C. Right, here we are. This is the question indeed. Find the values of A, B, C such that the equation of the plane OPQ is R dot 1AB is equal to C. Okay, so how are we going to do this one? Now, this is the equation of the plane. We're talking about the plane OPQ. So we're looking at vector PQ. We found earlier on that vector PQ was 2, 1, 2. Therefore, maybe we can use the matrix method. 2, 1, 2. Also we have PQ here. We also have OP. And OP is given in the question as 1, 2, 3. So 1, 2, 3. So let's take a look. You block this, you're going to get 1, 2, 2, 3. So 1, 2, 2, 3. The one in the middle, and you're going to get 2, 2, 1, 3. So 2, 2, 1, 3. The last one, 2, 1, 1, 2. So 2, 1, 1, 2. 1 times 3 is 3. 2 times 2 is 4. 3 minus 4 is minus 1. So we got minus 1. X minus 2 times 3 is 6. 1 times 2 is 2. 6 minus 2 is 4. So we got then 4y plus 2 times 2 is 1. 1 times 1 is 1. 2 times 2 is 4. 1 times 1 is 1. 4 minus 1 is 3. 3z. All of that's going to be equal to d. Therefore we're looking at minus x minus 4y plus 3z is equal to d. In this particular situation, d has been replaced as c. We know that d is equal to c. Right, now maybe we can use probably a itself. Alright, a is 1, 2, 3. Sorry, well 1 minus 4 1 minus 4 is minus 3, plus 3 minus 1 minus 4. So I'm trying to see which coordinate we can use, because we've already used, so maybe I can say this is going to equal to x plus 4y minus 3z is equal to minus d. So we clearly see that this is 1, this is 4, this is minus 3, so this is 1 as given here, 1, 1. A is this one, so A is equal to 4, B is equal to minus 3. So if I substitute xy, because P is also a coordinate in here, so if I substitute 1 and then 2 here, it's going to be 1 minus 1 plus 2 is, no, it's not going to be alright. What if I take 3, 3 and 5? 3, 12, okay, let's say 3 plus 4 times 3 minus 3 times 5. This is what we have. 3, 3, 5. 3, 3, 5. So it's going to be 3 plus 12 minus 15. So 15 minus 15 is equal to 0. So clearly C is equal to 0. So here are the values of A, B and C as required. Okay, take care.